Now let's take a virtual tour inside the Greenwich Wastewater Treatment Plant with Alyssa Beck. Alyssa, can you please describe the overall layout of the Grass Island Wastewater Treatment Plant from the influent to the effluent?
Yeah, so the influent comes in off the street and it goes to our headworks building, which is where all the pre-treatment happens, like the bar screen and the grit removal. After pre-treatment, the flow moves into the primary settling tanks, where solids either settle or float out. And from there, the flow moves into the aeration tanks, which is where both our secondary and our tertiary treatment occurs simultaneously. After tertiary treatment, the flow moves into our final settling tanks, where all of the solids that accumulate in the aeration tanks are removed. After the final clarifiers, the flow moves into the UV channel for disinfection, and then out into the harbor.
A bar screen is typically the first level of physical removal used by a wastewater treatment plant for incoming wastewater or influent. The bar screen is designed to remove objects such as wipes, rags, and plastics from the influent and protect the pumps from clogging. Some bar screens are old and may be rusted or degraded and otherwise compromised. When you visit a plant, check to see if the bar screen is in good working condition or if certain trash may be getting through. Besides bar screens, other technologies such as rotary drums can remove solids with screen sizes down to 0.002 millimeters. This is typically followed by oil and grit removal by grease trap and aerated vortex. The ability of a wastewater treatment plant to handle physical debris facilitates its operational maintenance and biological treatment of the sewage. Are there any issues with objects getting through the bar screen at the Greenwich plant or problems with clogging?
Like many in the wastewater industry, we do have a lot of issues with so-called flushable wipes getting into our equipment, and there also can be instances where foreign debris does make it through the sanitary sewer system. For instance, I remember one occasion where we had over 100 feet of large rope make it through, like what you would use up to tie a boat at a dock.
How does the treatment plant remove oil and grit from the influent?
So after the bar screen, the flow moves into an aerated grit chamber. And in the grit chamber, all of the heavy grit settles to the bottom of the tank. It's pumped off the bottom of the tank and it goes into a vortex grit washer. And essentially we're rinsing the grit to remove organic material from it. And then after that rinse, it goes up on a grit snail, which is like a conveyor belt, and it removes the rinse water by gravity. The grit then moves into a container and is landfilled. The flow after grit removal moves into primary tanks, and those primary settling tanks serve not only the purpose of removing heavy solids that settle out, but also removing anything that floats to the top, like fat soils and grease. So the fat soils and grease float to the top, and then they can be skimmed off and removed from the flow.
The primary treatment of wastewater involves sedimentation of solid waste within the water. Water is passed through several settling tanks or primary clarifiers that separate water from contaminants. This is done to reduce the biochemical oxygen demand, BOD, and total suspended solids, or TSS, within the water. The resulting sludge from solids is then either disposed of as is or fed into a digester in which further processing takes place. The secondary treatment of wastewater involves processes such as aeration that enable microorganisms to biologically remove organic matter and contaminants. The microorganisms consume biodegradable soluble contaminants such as sugars, fats, detergent, and food waste using aerobic and anaerobic processes. Secondary clarifiers separate biological floc from the treated liquid waste stream and are often used in conjunction with suspended growth biological wastewater treatment plant systems. So Alyssa, can you please describe how the secondary treatment process at this wastewater treatment plant works?
We're an activated sludge plant that uses air both for mixing and for providing oxygen to support aerobic microbial activities in the aeration tanks. Activated sludge means that when the solids settle out in the clarifiers, they contain a lot of healthy active microbes, and we return those healthy active microbes back into the aeration tanks so that those microbes can eat fresh food that comes in with the influent.
Tertiary treatment of effluent involves additional steps during or after secondary treatment to further reduce organics, turbidity, nitrogen, phosphorus, and pathogens. Tertiary treatment may include processes like microfiltration, ultrafiltration, and reverse osmosis. Other examples include activated carbon adsorption of organics, ion exchange, advanced oxidative processes, maturation ponds, and additional disinfection. Sand filters and bioreactors are tools that may be used in the tertiary treatment process. So Alyssa, does the Greenwich plant use tertiary treatment? And if so, can you describe how the tertiary treatment process works?
Our secondary and tertiary treatment are occurring simultaneously in the same aeration tanks, which have distinct aeration zones. Some parts of each basin provide a lot of air that support aerobic microbial activities like the removal of organic matter, which is a secondary process, or the conversion of ammonia into nitrate, which is a tertiary process. Other parts of the aeration basins provide only enough air for mixing, and they support anoxic microbial activities like the conversion of nitrate into nitrogen gas that's released into the atmosphere, and that's also a tertiary process.
Sewage treatment plants in the U.S. typically use chlorine or ultraviolet radiation as methods of disinfecting the final effluent. Chlorine is the most widely used disinfectant for municipal wastewater systems. It destroys pathogens by oxidizing cellular material and is effective against a wide range of organisms. It also has a residual effect which prolongs disinfection after the initial treatment. Unfortunately, it can be toxic to aquatic life, so many states require dechlorination. Studies conducted by FDA and others have shown that chlorine disinfection may not be as effective against viruses and parasites compared to UV. Ultraviolet disinfection uses UV radiation to penetrate the cell wall of an organism and destroy the cell's ability to reproduce. It is very effective at deactivating viruses, spores, and cysts in addition to bacteria. So Alyssa, what type of disinfection method is used at the Greenwich plant?
We use UV disinfection continuously on a year-round basis.
Would you please describe the UV system, like the UV dosing, number of bulbs, and banks?
We have a Trojan 3000 UV system with 3 separate banks, each consisting of 152 bulbs. Our UV dose is set to a minimum of 40 millijoules per centimeter square, and it's based on readings from the UV transmittance in the water. So if the water's dirtier, the system will increase the intensity of the UV light or turn on an additional UV bank to meet the minimum dosage set point. Or if the water's clearer, we won't have to run with so much intensity.
How about redundancy?
We typically operate with just one UV bank on at about 60% intensity, which leaves the other 2 banks being redundant. This allows us to perform maintenance on the bulbs following manufacturer specifications. That maintenance can include cleaning or changing bulbs. We do have automatic wipers that help to keep the bulbs clean for continuous use. However, during larger storm events, we can have instances where we're running with 2 or even all 3 banks online to meet our minimum dosage set point.
Can you describe any scenarios which disinfection might be bypassed?
We have no option for bypassing disinfection as a process control decision. However, rarely at really high flows, we may have instances where the water column of the UV channel is so high that it's running above the effective level of disinfection, like above the bulbs. In that instance, the top of the water column may not be effectively disinfected, and we may have permit level exceedances. However, that's really rare, and during normal operation conditions, the level control gate at the end of the UV channel helps to maintain the level at the appropriate height so that we're getting adequate disinfection. And at our normal operating conditions, we typically see fecal coliform and enterococci counts in the single digits.
How is your microbial quality of the effluent determined?
We perform both fecal coliform and enterococci counts 4 days a week on samples taken during peak flow times, usually around 11 a.m.
Do you have an in-house lab, or do you send the effluent samples to an outside lab? And how long does it take to get a sample result if there is an exceedance?
We do all of our bacterial counts in-house. We use the IDEX QuantiTray system. And so the way that method works is you're actually growing microbes. So they grow for about 24 hours. So when we set up a sample, about 24 hours later, we'd be reading out that sample. For fecal coliforms, the way it works is that the bacteria cleave a yellow dye off of the nutrient media that they're eating, and that yellow dye shows up as a color change on the QuantiTray. For enterococci, the process works the same, except it shows up as something that fluoresces blue under UV light. So after we take the plates out after about 24 hours, we essentially just count how many wells we see a color change in, and then we look up those numbers on a reference table to determine the most probable number of fecal coliform or enterococci in that sample that we took. So within minutes of taking the sample out of the incubator, we know whether we're having a permit exceedance. And if we do have a permit exceedance, we're able to report that very quickly to our shellfish authorities. We technically have 2 hours to report any exceedances, but we would generally get a call out to the shellfish authority within minutes. As you noted earlier, the time of travel from here to the approved harvest area is about 6 hours, so that would allow the shellfish authority to close any growing beds that needed to be closed because of the exceedance.
Are there any chemical contaminants of concern that may be discharged in the final effluent?
We don't have any known contaminants of concern in our effluent.
Final effluent is discharged from a diffuser pipe that extends from the final UV disinfection channels out into the water body. The effluent pipe is anchored to the bottom, and effluent is discharged through the multiple ports or diffusers. Can you provide a detailed description of the diffuser?
So disinfected effluent moves from the UV system through a 54-inch diameter pipe to an outfall chamber where it's hydraulically split and then discharged into Greenwich Harbor.